afternoon. Well, so we're this lunch session always. I think maybe half of the audience is still at lunch hall. We'll get started and we'll introduce ourselves. So then we hopefully it's exciting 75 minutes for you. My name is Lindsay Allen. I'm with Azure SQL Data Platform engineering team.
I'm in Lindsay's team and working on Azure SQL Database and SQL Server Engine.
Just stand closer here. And my name is Joachim Hammer, and I'm also in Lindsay's team, and I work on security and customer engagements.
Thank you. So we'll move ahead and look at this agenda, right? The layout for the next 70 minutes. And we will start with give you a quick overview and a look back of this year, because we've been continuously releasing to cloud. And from January to September, we already done a lot, GA'd lots of capabilities. Going to give you a quick look back, and then we can get into what's new. What's new in platform? We have so many new features, capabilities, product. So we try to group them, right? So what's new in the platform? Lots of them, if you went to keynote, you probably already heard. How many of you went to Scott Guthrie's keynote? Oh, about 30% of the room. I was hoping most people are there. So then some of these might be still new to you. And then what's new in security, advanced security? We have the leading, most advanced end-to-end security in our platform, in database as well. For data privacy, we have actually, our analyst was telling us, it says it's a government grade. We actually do certify. We have lots of certification with government worldwide, different government. And then what's new in intelligent database? We put in lots of intelligence, machine learning, and lots of bots and lots of patterns into our platform. And we build our engine to be adaptive, learning from your data and to optimize, and what's new in intelligent database. And next is what's new in the reliability, resiliency. We have everything built in, but we continue to improve, enhance, and to show you what's in there. Then we're going to wrap it up. So I'm going to start with the first part, introduction. So you've probably seen this before. I just want to reiterate, Azure SQL Database is a fully managed SQL Server. It's exactly same bits and binary running in cloud and also running in a SQL Server. So the difference is we released to cloud a lot faster. And so the code are tested and deployed in Azure SQL Database first. And some of the features, because if it's not applicable, it might be hidden and by the feature switch, but the binary are the same. And it's continuously being deployed. And we have deployment trains running every day to actually deploy through all the stages of testing. We have 3 testing stages. We have canaries. Then we roll out worldwide, right? And so always in production, and we roll forward. If you go to past service, this analyst said, 2018 is the start of Cloud 2.0. Cloud 2.0 means it's a past service, right? And so past service give you these fully managed. You can treat your database like utilities now. I just thought about 20 years ago, I actually worked with a startup and tried to put relational database in the telco switches. And so make the routing switches smarter, right? You can actually do more complex routing and select everything. And 20 years ago, I think that was too far ahead of its time. And now I think this past service database as utility is ready. We can actually taking care of your database, like put your database in autopilot, and you can focus on your business. You don't have to worry about the chores anymore. And since I said, SQL Server, fully managed SQL Server, right? How did we do this? Is very high level and architecture. So what we did is we built upon Azure infrastructure, right? And Azure now is in 54 regions, and there's a storage layer, then there's a compute layer, right? And the network, accelerated network. And then there's Service Fabric, orchestrate all the applications. And Service Fabric is like application cluster. And you might be familiar with Kubernetes, but Windows Fabric, Service Fabric existed before that. And there's always Yarn, right? Yarn++ or similar. And in its architecture purposes. And built on top of this resilient, very, very extremely scalable architecture. And we actually built lots of DevOps intelligence. And in order for us to run millions and millions of databases across the world, right, across all these regions and data centers, and we needed to use automation, to use intelligence to run the service. So we have lots of intelligence built into the platform, and we also surface it and to your application and service. Think about there's, you know, the show plan will show you a missing index, what have you, and either you leave it or leave it alone, right? Sometimes lots of hassle to actually look at the query plan, run at it one after another to see if I want to create index or not, right? And all this will be done for you automatically. You can do these advanced tasks now, right? You can actually write very complex SQL statement, SQL store procedures for your application, but you don't have to worry about the basic anymore, right? You don't have to worry about the kindergarten level of query optimization. Machine can do that for you automatically. And not only optimize for your performance, the advantage of optimizing for your performance is can optimize for your cost. So now you will have a very little chance of runaway queries. Burning your CPU, not doing work, you know, hate to see those spin locks, right? And they just counting integers, not doing anything. So when you avoid all these runaway queries, you will use less CPU. You don't have to over-provision. Our IT, like 5,000 databases, taking automatic cost optimization because we can look inside your workload, right? Not actual data, but the patterns. And they saved almost $4 million over the course of a year. So lots of these, I think we have more in-depth sessions. And then there's a flexible on-demand scaling across the slows, up and or down, and this is all online, right? We can do all this. It's very elastic. And we have resource governance for your workload. If you want, you have a budget. If your CFO gives you whatever limited budget for your cloud spending, you can actually set that spending limit for a collection of databases. And this feature, Elastic Pool, actually will limit the spending of a collection of databases. And the trusted, we have everything built in, zero data loss. You don't actually have to worry about HADR, backup, all that, right? It comes with the service. And we guarantee zero data loss, and we guarantee 4 nines SLAs availability. And all the security and government-grade security and privacy. So look back a little bit on these, this year. So earlier this year, what we released is a TDE integration with Azure Key Vault. So you can bring your own key, and you can manage your own key in separate storage, secret storage, and not actually have to manage by SQL with the SQL anymore. Long-term data retention and support up to 10 years. If you have regulations, you need to keep your data for 10 years, right? And we also launched vCore-based business model. So now we want to make it easier for you to understand your workload, to planning, to purchase the services. This is alongside of a DTU model. We're not retiring DTU, and this just makes it easier for you to purchase. Also easier for you to transfer your SQL Server license to Azure PaaS, because the SQL Server license is based on cores, right? And the next thing we have with G8 generally available advanced threat protection, vulnerability assessment. All these is just in time for GDPR to kick in May, right? And then we have zone redundancy, GA, data sync, storage add-ons. So now you can have a S4, like a standard size 4 of database, have a 500 gigabytes, and a resumable online index creation and elastic jobs. So finally, we have a jobs for our elastic pools. And we went to public preview of a managed instance business critical skills. This is shared nothing storage And then we have, we GA'd the LTR and failover groups, automatic failover group across DC. And then in August, we made it generally available of reserved capacity for SQL database. So reserved capacity is, I think, VM called a reserved instance. So if you want to pre-commit or reserve for 1 year or 2 years or 3 years, a number of cores, and you get very, very significant discount. So now bring us to September. Now we had a lot more announcement, very exciting announcement this week, and we're busy talking to the press, to the media, and to the reporters. So the four buckets we're going to share with you, and we're going to demo, and some new capabilities. I will start with, we finally announced and generally availability of SQL Azure managed instance. And that was yesterday at Scott, our executive vice president, Scott Goose keynote. And we happily to tell you, we have actually many customers already in production and in managed instance. And we're very happy, excited to bring this service and to generally available. And we started this project only about 1.5 years ago, and codenamed Cloud Lifter. And the second one is a couple of years in the works as well, called SQL Database Hyperscale. And this is groundbreaking. The reason is we got around the speed of light, and now restore database. If you went to the Rohan's, our boss, Rohan's keynote, you will see restore 50 terabytes database, and now take minutes, right? Because we don't actually move data pages around anymore. We can do snapshot. How many of you tried to restore 10 terabytes, 50 terabytes on-prem database? I don't care which database engine. How long does that take, 10 terabytes? Days, yeah. 50 terabytes will take a week if everything is you're lucky, or if you can actually swing your lungs around. And the restart generally will kill you, right? It's like it just take forever. So you will see restore 50 terabytes database now going to take minutes, because we had a major architecture change, and lots of these operations and the scale operations, it's not going to be size of data operations anymore. So we can support very large database in the cloud on commodity hardware. Then we have reserved capacity GA. So now, look at Azure SQL Database have 3 deployment options now, right? For 9 years, we had a singleton database. You just go create your database, right, in multi-tenant model. And we added the elastic pool for your govern your resources and share resource across your databases. This is about like 3 and 4 years ago. And now we actually introduce another one, and called this managed instance. Managed instance is single tenant model and have resource governance, and actually surface a lot more native and favorite capabilities of SQL Server, and make it a lot easier to migrate and to meet all your compliance, security, and regulations. So here's what it looks like. We can actually, when you want to create managed instance, it will actually inject into your own subnet. And your VNet or Azure VNet can be part of your subnet, connect to on-prem through express route or VPN, right? And depends on how you define your subnet mask. And since this is a native Azure VNet, and it supports Azure VNet peering. So you can actually, will have its own dedicated IP address to do internal routing, everything, and so it will keep it secure, doesn't need to have a public endpoint on the internet either. And so in order for us to put all this, we did lots of engineering work. We did lots of work to actually support HADR across regions. And because now this is isolated, it's secure for you, it's secure for our infrastructure as well. So you can restore native backups. And lots of native features, SQL Agent, CLR, we're just working now. And we actually make it easier to help you get there as well, right? We have a database migration service, help you assess and create managed instance and migrate your database there. Just make it easier for you to do that, right? And then we support transfer your SQL Server license We have certain amount, about half year or year, do usage right. And during a migration, you don't have to buy a new license. And then all the experience, all the benefits of SQL Server combined with all the intelligence of a PaaS platform service together and give you a very powerful platform in the public cloud. It does all the chores for you too, so you don't have to patch ever again. You don't actually have to upgrade again. No more version upgrade, right? Imagine version upgrade, apply CUs, apply service packs, lots of work. So it is a GA bits now in the portal, and the GA price is taking effect on October 1st. Business critical is still in public preview phase. So one of our early adopter customer is a GE Healthcare, and they have this patient care application. This is ISV portion of GE Healthcare. And they deploy one deployment per hospital, or they call it per tenant, right? And it depends on the hospital size, the database is different size. They generally have 5 or 10 databases per deployment. And this is all SQL Server application and the .NET application, SQL Server.NET. And it's actually quite challenging for them to deploy this in their own data center and provision and with their sales force to land their customers, right? Because they have to have capacity there. If a customer doesn't come, they sit on this inventory of hardwares, right? So that's why with cloud, they like cloud. They don't have to worry about hardware expenses. They don't have to worry about CapEx. There's only OpEx now, right? Because we're carrying the CapEx expense. We're running our own data center. They don't have to. So they moved one of their tenants to cloud without actually taking any application change. Everything just works. It takes a few months, and everything just works. I think we had a video case study last year about the GE Healthcare. So hyperscale, I know there's a session just finished on hyperscale. Kevin gave the session. This is a fundamental architecture change, so really it's a new database and of SQL Server. And we took the SQL Server component and the compute, the query processing, and the query execution, storage engine, log manager, everything, and we turned it into a microservice architecture. When they're microservice, each service can be actually deployed, distributed on different components. This is how we can actually run the 50 terabytes, 100 terabytes, and even bigger databases on commodity hardware. And the infrastructure, the performance of network improvement in Azure helped this in great deal, right? And so instead, I get into all the detail. This slide is very dense. And I'll invite Ajay here to demo, actually show you the impact. And I invite you to go look at the recording of Kevin's hyperscale session. And our goal for the hyperscale is my first slides. This is part of our platform, and we will make this available to all relational services in cloud.
Hello? Okay. All right, so before I show you how quickly we're able to restore, let me go ahead and kick off the restore, and we'll talk about this architecture, since it's going to take a few minutes. So here I already have provisioned a hyperscale database. The first thing I want you to see that is it is 50 terabytes and almost 93% used. So restore is very simple. I mean, one of the things we want to make sure is we meet our SLAs. So we do have built-in point-in-time restore capabilities. All you have to do is click the button here and give it a unique name. So let me just call it night. And it tells me how far back I can go in case there's a disaster and you want to roll back, or if there's an accidental delete. So let me just flip it back 1 hour. And then click OK. So that's it. So while this is restoring, let me flip back to the slide. So how are we able to do the fast restore? One of the things is we have separated compute and storage. So what that means is SQL Server database pages and files are actually residing on Azure storage, which you see at the bottom, and the compute layer is completely independent. So we are able to now take file snapshots of all the databases pages. So if you have a large multi-terabyte database, like 50 terabytes, we will break it down into 1 terabyte files, and then we just have to do file snapshots of those. So this is like taking volume snapshots if you're used to doing that on-premise, which is how we're able to restore it really fast. And once that is done, we just have to go and hydrate all the caches. So this, as Lindsay mentioned, it takes it happens very quickly and very fast. So let me go back to my slide demo. So the restore is still happening, but meanwhile, I can show you the one which I had already completed just earlier today. So you can see, sorry. Yeah, so here's my history of deployments. So I had done a restore earlier today, as you can see here, and this took 6 minutes. So you're up and running in no time, so you can take any region in the world where this is available. So right now it's in preview in few regions. We'll expand it slowly, and you'll be up and running in no time. So let's go back. So the last part of this is reserved capacity. Lindsay mentioned this is generally available, and this is also available for any deployment option you pick for Azure SQL Database. So the main advantage is if you have Azure Hybrid Benefit, which comes with SA rights, you get license exchange where you can basically use your on-premise license and transfer them to Azure Database. And you have 180 days of dual use rights where you can use the same license without having to buy new licenses. That gives you significant savings. And on top of that, you can reserve capacity. But what we mean by that is you can, when you go to the reservation portal, you can pick how many years you want to reserve or commit to Azure SQL Database. So we give you 2 options, 1 year or 3 years. So depending on which you pick, you get additional discounts. And here's an example with 8-core managed instance running in US West, about 730 hours per month. So the same database with the same cost that you would do without this, if you had added reserved capacity in Azure Hybrid Benefit, it'll only be 20% of the total cost. And you'll get the exact same number of compute and storage requirements that you have originally. So take advantage of this. It'll give you huge benefits and savings. And this is only for running SQL database on Azure. So with that, we'll move on to what's new in security. I'll invite my colleague Joachim to talk about this, and I'll be back later. Okay, that's still going.
All right. Okay, so before I start on this slide, let me just say that we have a number of sessions actually that go a little bit deeper than a graphic here. So there's 2 security sessions tomorrow. There's another one on Thursday, or actually there's 3. So if we don't catch everything here, we can't do everything here. We have deep dive sessions tomorrow that I'm running with my colleagues. Security, what's new? Yeah, like I said, we can talk a lot about it. We pushed forward in different directions, let me say it this way. On one hand, you notice we have enlarged our portfolio, and so it was, of course, important for us to build security across the portfolio. So managed instance is a big thing for us and for our customers. So we spend a lot of time making sure that all the security features that you have got to use and that you like and appreciate also work in managed instance. In fact, we did a little bit better there in some ways. For example, on the VNet side, we have VNet private IPs in managed instance. We're still struggling a little bit with singletons and pools there, but by and large, one of our initiatives for this past year has been to make sure that all of our services have the same security features. So that was one area of investment that we've made. The other two investments are along the lines of we're pushing ahead with intelligent protection or intelligent security. We're still not fully landed on a name there. And this really goes to the fact that, as Lindsay said, we're offering a PaaS service. And a PaaS service means that everything has to be built in, including security and privacy and compliance. And so this is very important for us. This means that you have to change your operational workflows a little bit, but in return, you can expect a lot more protection than you probably get when you run SQL Server on-prem or any other relational database on-prem. This is based on the telemetry that we have. This is based on years and years of expertise and experience in running services. So for example, this last year, we really beefed up our internal protection through blue teaming and red teaming. So we really enlarged those teams. And so we have that as an internal service that we're now running, where we have folks constantly doing pen testing against our databases and so forth. And then we have a blue team that's constantly trying to protect and patching holes and building a fortress around our production clusters. But on the feature side there, we have, of course, I'm sure you're all familiar with, we have a triple of features that fall into this intelligent bucket. And that's, of course, vulnerability assessment, which is this rule engine that you can bring to bear to learn about any potential vulnerabilities in the configuration of your database. And so this is that top bucket there. And so vulnerability has been around for a little bit. We've GA'd it, so that was great job by the team. And they're actually continuously improving it. So we're not just giving you a bunch of rules. Now, as you may have seen from a recent blog post there, we're now moving a little bit towards this sort of allowing you to manage your resources at scale. So the V8 tool has now scripting capabilities where you can do exactly that. You don't have to connect to a single database, run your engine there, detect the vulnerabilities, do the mitigation. You can do this at scale. There's another step towards making sure that these features are enterprise ready. So vulnerability assessment is a cornerstone of, or should be a cornerstone of everybody's sort of security strategy and protection strategy. And that works, of course, for singleton pools and managed instance. So I invite you to try that out there. And then we have, again, part of this triple of features. There's threat detection, which works in conjunction with auditing. And this is this capability that runs 24/7 and basically detects unusual activities or behaviors against your database. And these, as part of our team in Israel, I think Ron is here in the audience somewhere. There he is. Ron, hello. As part of what they do in Israel is they have enhanced this tool with additional algorithms. So as you may know, we were able to detect injection attacks. Now we can also, this has been enlarged to detect exfiltration of data. So if you have a pattern of only like returning a few tuples in your workloads, and all of a sudden we notice that there's megabytes of data flowing out, that will also trigger an alert. Or brute forcing of passwords, again, that would trigger an alert. So as part of this contract with you, we are continuously enhancing the capabilities of these tools. And so if you go to Ron's session on Intelligent DB, he'll go into great detail about all the capabilities that are in threat detection. And like I said, this works with SQL auditing. And we have some more good news there. So again, we enhance the capabilities there by integrating that with OMS. So you can actually now flow your audit events either to an event hub or to log analytics for further processing. And if you come to our SQL DB session tomorrow, we'll have an exciting announcement to make there. I won't give it away yet, but yeah, so that's, we'll talk about that tomorrow. And so that's vulnerability assessment, threat detection, and I forgot there's also data discovery and classification. That's part of that triple, and that's in public preview. And then on the other hand, we are also pushing ahead with our sort of advanced or sort of the foundational security capabilities. We've made a lot of improvements in our integration with AAD, Active Directory, Azure Active Directory integration. That's going forward, and that's our main way of authentication for the cloud. And so again, tomorrow I'll show you a few things that we have done there. I'll stop here. Actually, I'll end the session with just a couple things on encryption, and I'll show you a quick demo. Encryption, Lindsay mentioned it earlier as well. We have all the different types of encryption, including encryption at rest, encryption, network encryption, and we are offering now integration with Azure Key Vault, so that you can actually decide do you want to use service-managed keys that we provide, we provision, we rotate, or create your own, upload it, or create it in Azure Key Vault and use it, and then manage that on your own. I didn't say anything about always encrypted yet, so that's my finishing touch here. So this is our encryption technology that allows you to essentially retain control, complete control over the master key, and so that's not stored in SQL Server or in SQL DB, and that protects against intrusions on your or somebody attacking SQL Server or SQL DB. And it's because that information that you encrypt with always encrypted will remain protected there, and there's no key material that any kind of intruder can find there. So we had a version that is running now both on-prem and the cloud. Generated great interest. The main limitation was that we only supported equality operations against these always encrypted columns with deterministic encryption. So that's a great downer. But we've taken the feedback. In fact, that was always our plan. We pushed forward. And so I want to leave you here with a quick demo showing you what the next version of Always Encrypted looks like. In fact, it was just announced yesterday for SQL Server vNext, CTP2. And it's coming to Azure pretty soon. Yeah, let me see. My machine here needs to somehow. My machine got rebooted. Let me just bring up my VM again. Okay, let me start up my VM again here. Sorry about this. So what I'll show you is we have this, let's see if it comes up. Here we go. So running this little web app, Contoso HR, and the usual setup here, we have a number of, so this has a table, and background has a SQL Server running with a bunch of customers in here. And now what I can do is I can query this. I can put, for example, a range predicate on the salary, or I can actually do a query against social security number, for example. And so that's nothing unusual here, except if we look at what's running at the background, we have SQL Server, like I said, we have a table called Contoso HR. And if you look at this here, we have Social Security and salary encrypted. In fact, we are using, let me show you here. So we're using, whoops, it's a little bit slow here. We're using randomized encryption, and so salary and social security number are encrypted. And one last thing, if we look at the extended event session here, you'll see that all these queries that I was sending are, in fact, encrypted. So this is evidence now that with Always Encrypted running, we can actually support a much richer set of queries, range queries, like I said. In addition to the like predicates, there'll be arithmetic operations and so forth. This is currently running, like I said, against SQL Server on-prem. It's using Windows vNext VBS Secure Enclave technology. It's coming to Azure soon. We don't have a timeline yet. It'll be also running on Intel SGX. And if you want to know more about this, you can go to Jakub. My colleague Jakub has a session on Thursday where he's going to talk in greater detail about this. So I'll hand it back. I'll leave you with this, and I'll hand it back to Ajay.
Okay, so the hyperscale did finish restoring. You can see that it took around 7.5 minutes. So I was not cheating. So let's go back to the presentation. So the next category or class of investments we have made is in the intelligent database space. And let's take a look at what we have invested here. So some of the things are making the query performance experience better, right? As Lindsay mentioned, you do not want to troubleshoot queries and sit and tune queries at middle of the night or during off hours. And we have invested quite a bit of this. That'll take away a lot of the common pain points. The second set of investments is in Graph. Graph seems to be a very popular and important scenario. And having the engine inside SQL Server makes it more powerful. And then we are now moving into a more interesting space called approximate QP, and I'll talk a little bit about that. So when it comes to Graph, Graph was introduced in SQL 2017, as some of you folks know, along with Azure SQL Database last year, but we have continued to invest here. The first one is merge DML. So this helps you run match queries. So Graph uses the match keyword to go and find relationships between different nodes and edges. So now you can use Graph queries with merge syntax. So if you have a graphical database where you have account holders and credit card information like this, and if you want to update some information, let's say somebody has changed address, you can use it with merge statement, which will also work for upsert scenarios. The second thing is view or derived tables. And this is really powerful because today, if you don't have this, without this, it'll take you having to write a complex common table expression with a lot of joins. And not only is it complex to write, it's also very error prone. It's very possible that you missed something, so you cannot get the right results. So with the support for view and derived tables, you can use this in line with match syntax again, as you can see in this example here. And this will, again, greatly simplify your development experience with Graph. The last one was around edge constraints. This is mainly for defining business rules. So you can actually add constraints to your edge tables and say a certain relationship should not be allowed, as you can see in this example, where the hash address table only has connection from one way, from account holder to address. So let me quickly show you a demo of how you can use Graph to do some cool things like fraud detection or identifying shared connections between different account holders. Okay. So I'm connected to a database running on SQL Server. I've already created the graph and graph tables here, as you can see. It has both the node and edge tables. So just a quick primer, think of node tables as your primary data tables, and then edge tables are the relationships between these node tables. And very useful for relational analysis and building some complex algorithms. You can actually integrate this with ML and also improve your fraud detection. This can be your input to your ML data source. So the first demo I want to show you is I have a few views defined. So let's say I have account holder, credit card information, bank account information. So these are all stored in different tables. So in the view, I have basically defined that anything which looks like contact For example, if it's an address, phone number, or SSN, which can uniquely identify somebody, I define a view which unions all this. Similarly, I have a relationship defined on edges for hash contact. Likewise, I have defined other views for credit card, so where basically it looks at credit card number and credit limit, and account number and loan amount. So these two are union together. So anything which is similar data types, I have made the views. Now, let's say you want to find out, usually the way fraud rings work is there are usually a lot of many people involved, so it's very hard to bust the ring unless you find some kind of intelligent relationships. People share contact information, security, social security number, etc. So if you have a large table with multiple accounts, it's very hard to quickly determine this. So in this, you can see that all I'm doing here is, with my support for views in match syntax, I'm checking if any account holder has contact in the contact info view. So just by doing that simple match syntax, I can quickly see it ran in less than, it says 0 seconds here, it ran in milliseconds, about 6,000 rows that were analyzed. And it shows here all the names which share what type of information they share. In this case, they share the social security number, and then you can see several different rows where multiple people share the same phone number, etc. And you can also see the ring size. So that can see that how many people share that information. Like in this case, 209 people share the same information. So very quickly and easily, you can do this complex analysis with graph. And another example here is financial risk. If you want to know if any people have taken a loan or have taken a lot of money charged on their credit cards, and they have a high risk of just disappearing and causing financial losses for the bank. So here I am looking for anybody who is sharing credit card information and is in the contact view that I defined previously. So if I run this query, again, you can see similar information like the previous. You can see the different people and number of people sharing that information and how much financial risk they pose. So if this whole fraud ring were disappeared, then the bank would lose that much money. And so seeing all this in the database engine as rows and columns is good from a database guy's perspective, but for a business person, you want something visual, right? So there are multiple ways to do this. So there is a JavaScript library, d3.js, which you can integrate with your app, and you can pull this data there as a JSON and then visualize it. Or here in this example, I have a Power BI, which basically points to that node and edge tables that I defined, and I can visualize it here, and I can filter it by my contacts. So let's say I want to know who's sharing the social security number. I can just filter it and look at this here. So very quickly, you can visualize all the networks built. And you can also feed this to your machine learning algorithms, as I said before, as your input to build more predictive analysis on top of that. So that's the demo for graph. So let's go back to the presentation. So the next category of enhancements is in what we call intelligent query processing. How many of you have seen any of these things in your day-to-day job? I'm sure quite a few of you who have worked with databases run into issues with this. So one of the things that we run uniquely in Azure for SQL Database is continuous monitoring. Right? We collect about 500 petabytes of data every day, and this telemetry helps us continuously monitor and auto-tune most common problems, and you don't have to worry about it. So we are continuously expanding this tree. So the next set of improvements we have is in the space of either table variable deferred compilation. So one of the challenges with table variable is it has a guesstimate of one row. So if you have a lot of rows, it can pick an inefficient join, and it will result in a poor plan. and which can be a poor query performance for the application. The second, so the change we have done there is we are deferring the actual compilation till the first execution. So we will have actual statistics of how many rows are in the table, and we will be able to pick the right join type. The second thing in this adaptive query processing is memory grant. So biggest challenge with memory grant is done at beginning of query execution. And unlike compile memory, execution memory cannot grow as it requires. So this can lead to two problems. If the cardinality estimation is incorrect, you can either have underestimation, which means you needed a lot more memory than what you were given. What does that cause? It causes spills to temp DB. So you will have I/O and query performance. Or the opposite problem can also happen where you overestimate, which means, let's say you needed only 1 megabyte of memory, but you were given 1 gigabyte because your cardinality was wrong again, which means you're affecting concurrency. You took away too much memory where other queries could benefit from it. So that will be the opposite problem. So with memory grant feedback, we can dynamically take feedback on how the query is executing, and each execution of the query will improve from the previous execution statistics. It keeps track of how much memory was given, how much was actually used, and we'll adapt to that till we reach a stable state, and I'll show you a quick demo. The third category of improvements, and this is a new problem space, is called approximate QP. And especially for businesses that deal with a lot of data, like big data in the relational world, think of it like warehouse queries where you're doing analysis or modeling or experimentation on a lot of data, like data scientists. You do not want to spend time on writing aggregate queries on large data sets, which can take significant amount of time. One such problem is count distinct. So if you are familiar with how count distinct works today, it's a size of data operation. What I mean by that is, depending on the number of distinct values in your table, we will have to read all that data into memory and then do the count on top of it. So it costs both I/O and memory, right? So it can take significantly long time. So approximate count distinct is a new research that was done by a professor in one of the French universities, I believe. You can look up hyperlog algorithm. And this basically has a constant memory grant. It only needs 1.5 kilobytes of memory. And again, I'll repeat it, it's 1.5 kilobytes, no matter what the data set. And they can accurately predict up to within 2% of accuracy. So 98% will be accurate. You'll get the right data set. So it's very useful for scenarios where you are able to live with that 2% error, especially if you're doing like modeling and looking at analytics. Not good for financial industry. You don't want approximate count distinct there, but definitely powerful for a lot of data warehouse scenarios. So let me show you a couple of demos. Okay, so here I have a large database. Basically restored the worldwide importers database, data warehouse version of the database to Azure. And in Azure now and also SQL 2019, we have this new compat level. So I'm going to set that compat level. I'm going to clear the procedure cache just to make sure that we are not running with any stale information. A little bit of a lag here, okay. I think I lost the network. Let me check. Okay, this is back. Okay, so I'm going to create a sort procedure which basically does a large sort and large order and hash join, and we will use this to simulate memory grant issues. So the first time I run the sort procedure with value 8. There is no data in the table which has that value. So what's going to happen is it's going to run immediately and cache this plan. So it's going to optimize this query for a table which has no data. So it may pick, if you look here, it picked a hash match with table scan, right? And you can see that if you look at the memory grant warning, it already has, if you look at the bottom, excessive grant. Now, if I run the same thing with value 9, this should return about 1 million rows. It takes about a minute. And this, because the plan is cached, it's going to use an inefficient plan. So this is going to cause memory grant issues. So it'll basically do excessive grant, and actually it'll do under grant. So because you need million rows, so it's going to spill to 10 dB. And this is basically a poor query experience. So the first time we execute it, since we do not have any historical statistics for execution of this value, it will basically not have any information to go and adjust the memory grant. So this is the first time it's going to note down how much memory this query actually took. So subsequent executions will improve upon this. And we have added some insights into the show plan. So you can see it took 44 seconds about for 1.2 million rows. And if you look at the plan, you can see that it spilled data. If you look under the warnings, it spilled data to 10 dB because the memory that was given to the query was not enough. So now if I go to the plan properties and look under memory grant info, you can see that it's adjusting. Right? This is a new property we added, is memory grant feedback. So this value will keep changing from first execution, then it'll go to yes adjusting. It'll keep adjusting till it reaches a stable state, then it'll flip to stable state. So let's try running it one more time. And now it has history of how much it took and how much memory is actually needed for that query. So that subsequent executions should more accurately predict how much memory is needed for this query and adjust it accordingly. So you can see that from 44 seconds now it went back down to 12. And no changes made by my query, no option hints, no tuning required, no DBA intervention required. It just magically works. So, and you can see the warnings are gone, right? So if I go and look at the memory grant property again, it still says adjusting. If I were to execute one more time, it'll say yes stable if it no longer sees that it needs to grow or shrink. So that's your dynamic adaptive QP for memory grant. So the next demo I'll show you is the approximate count distinct. Just a quick recap, the memory grant one requires you to be on the latest compat level, 150, as you saw earlier, whereas I think the VM's having network issues, okay. The approximate count distinct does not need you to change your compat level. It should just work when you're on the latest and greatest bits. So here I'm going to run the same approximate count distinct. I'll clear the cache. Okay, so I have a count distinct and approximate counting. Note the new syntax. So both of them are going to go against the same table. So let's see how much time it takes and how what the results show, right? So I'm going to turn on the timer also so that we can see how long it took. And I will turn the graphical plan so you can see the difference in the plans that we generate. So what happens here is for the count distinct one, it has to pull in all the distinct values and then do the aggregation. So you're paying both the I/O cost and the memory cost there. Whereas for the approximate count distinct, as I said earlier, it's a fixed memory cost. And the new algorithm will be able to more efficiently do it. Plus, it can also parallelize your count operation. So we will see all these benefits as soon as this finishes. Okay, the first one finished. It returned a value of 46 million something, and the approximate count also finished. It took 45. It returned a value of 45 million. So your total count is within the 2% range. Now let's look at the plan. You can see that the first one ran a serial plan in the stream aggregate, whereas we were able to leverage parallelism for the second one. And if you look at the total execution time, the first one took around 36 seconds, and the second one took 4 seconds, so significantly faster. Again, this is definitely a new problem space, and a lot of customers working in the big data relational world, not the NoSQL world, but the relational big data world, really want these capabilities. Even Azure SQL Data Warehouse will since, as Lindsay mentioned earlier, we're running the same engine, this will be available in Azure SQL Data Warehouse and SQL Server on-premise also. Okay, let's go back to the presentation. So now let's look at what's new in reliability. So one of the advantages for customers or disadvantages for Microsoft is running the service with 4.5 million databases in 50 regions means we have to improve and make sure the service stays up and healthy, so that otherwise all our developers will be only doing DBA work instead of sitting and writing new features, right? So we spend a significant amount of time from the learnings to put the intelligence back in the service to make it reliable, available, and stable, right? So quite a few things we have introduced there in what we call enterprise reliability, and we continue to grow this. And I'll go in reverse order. The first one is resumable online index. So index maintenance is expensive. It takes significant resources, I/O, memory, and locks, which can cause application downtime. So for applications which need to or manage their downtime, if index creation goes beyond the allowed downtime, a lot of folks will have to kill it, right? Which results in long rollbacks, which also takes locks and time. So what we introduced earlier is online index rebuild, where you can pause and resume index rebuild. We can resume whenever it finishes. Second thing is we have introduced now is online index create. So if you're creating a new index, you can also do pause and resume so that you don't impact downtime. A second enhancement which is built into this is log space use. Index build takes a lot of log space and holds up log truncation. So with this, we have batched the transactions into much smaller transactions. So even if you pause the index creation or rebuild, you will not run out of log space. So that's a big benefit. The second investment to improve availability or concurrency is parallel PFS updates. Many of you here must have heard of TempDB contention. So one of the biggest challenges with TempDB, you have two types of problems. One is metadata contention, and the other one is allocation contention. So when you're trying to insert a lot of data into temp tables, we have to go find pages. So to find pages, we have a system page called page free space, or PFS. Which is where we go and find, it keeps track of all the used and available pages. So that's where every thread or every query needs to go and check. And once you find out what pages are available, you have to go and change the status of a bit in that system page. So that can lead to contention issues, because if thousands of sessions are trying to go and access that and try to update it, it's all done on an exclusive latch today. It can basically cause latch contention, right, and cause performance issues. So we recently made changes where we looked at how the contention happens, and in most cases, there's no conflict. Even though two threads may be updating the same page at the same time, they're not touching the same bit. So what we are now able to do is, under a shared latch, go and do PFS updates. So multiple sessions can go and update their bit in parallel. It's still done as an interlocked operation, so you will not have any corruption there, but it's done significantly improves the scale of your TempDB workloads. And the last one is accelerated database recovery. How many of you run into either long recovery issues or log space issues? And so with this, you no longer have to worry about either of them. And I'll tell you why. The top 3 customer pain points when we did survey, the survey data is at the bottom. More than 60% of customers say that they have more than 1 hour of downtime because of long recovery. And this is because recovery is single-threaded. So even though our transactional workload, if you're running business apps, can be updating databases in parallel, when you do recovery, we have to do one transaction or it go through in a serial fashion, and it takes a long time. And also, if you have a long-running open transaction, it can prevent log truncation from happening because you cannot roll back to the previous part of the log until the old transaction is cleared. Because if a virtual log file or a VLF is in use, you cannot reclaim it for subsequent transactions, which results in auto-grow. So to solve both these problems, before we do that, the way recovery works today, most of you must be aware of this. We have 3 phases. Analysis phase is where we go and look at the log to see what transactions need to be recovered. We build basically a list of all your VLFs which have committed and rollback transactions since the last checkpoint. Once analysis finishes, we have to do redo, where we start from the oldest active transaction, and then we go and look at all committed transactions since last checkpoint, and we have to replay them. And undo is basically undoing any transactions which were not committed at the time of the crash. So this is an expensive operation. It takes significantly long amount of time. So what we have done is we have introduced what's called accelerated database recovery. This is version-based. So today, version store is in TempDB. So what we have done with this is we have now a persisted version store where it's per database. So each database has its own version store. So you no longer have to use TempDB. It also solves other contention points with TempDB. And then we have introduced what's called slog. Slog is, think of it as a memory stream, and it's also checkpointed to the log, so it's persisted. So persisted version store keeps track of all your user transactions. Slog keeps track of all your non-user transactions. Think of it like system transactions. And because we have persisted version store, now we can do logical revert. What we mean that is, today if you do inserts and you do a rollback, we have to do compensation. We have to do deletes to compensate the inserts because the log is immutable, right? Once you write a record, the next record to replace it has to be opposite. With persisted version store, since we are maintaining all versions, you can do rollback immediately because you'll know what are the transactions you need to roll back. So you just remove all the versions and change your pointer back to the version which was before the transaction started. So your undo becomes almost instant. And we also have a background task which goes and cleans your version stores once those transactions are no longer required. So with that, your entire redo phase shrinks very significantly because now to redo, you just need to read from slog for all your system transactions, and for your user transactions, you just have to redo from your last checkpoint. And undo, as I mentioned, all we have to do is roll back to the version before the transaction started in the persisted version store. Just change the pointer there, and you can just undo instantly. So let me show you a quick demo which shows the actual value of this feature. Okay, so here I have a application. So the green line represents the accelerated database recovery feature on. It's a database level option. And then the red line represents rows inserted for ADR off, right? So you can see that both of them are inserting a ton of rows. One thing you will notice on the right side is the transaction log space used. So for the one with ADR on, since we can do aggressive log truncation, the reason we are able to do aggressive log truncation is you no longer need a transaction log anymore other than for the tail of your log, because all the data you need is either in slog or persisted version store if you need to do recovery. So we can actually go and reclaim all the log space. So here you can see that the log space was stabilizes at some point, it will not grow, so we can continuously keep truncating it, whereas without ADR, your log keeps growing significantly. Now, you can see that we have already inserted around 2.5 million rows. So let me go and crash this, and let's try recovery. So I go and stop SQL Server, as you can see here. Now let me start both the instances. Now you will see two more charts at the bottom. Okay, the first one is without ADR. It's just about 2,400 seconds. That's like 40 minutes, I think. And the right side is already done, 3 seconds. So you can see undo is instant. Redo took just 2 seconds. It's really powerful. And this is also the feature which is running inside Hyperscale, which allows us to restore a database and recover it and bring it online very fast. The other benefit of having this is failovers. So one of the biggest problems is, even though you have HADR implemented, whether it's always on or whether it's in Azure, once the primary replica goes down, even though you have an HA replica, it can still take a long time to come up, since we have to drain and redo all the transactions. With this, it's almost instant. So it's multiple benefits, like log space used, the recovery time, and then the failover time. So it improves your availability experience for your databases. As a result, your applications significantly. So let's go back to the presentation. So now then we have several other features which we have also introduced recently. One of them is zone redundancy. So this has been in preview since March. This basically is just one click. As you can see in the arrow, when you're creating the instance, you can say you want zone redundancy. In Azure SQL Database, we are the only cloud provider will provide built-in HA. When you create a database, if you pick the business critical SKU, we create 3 replicas for each database that you create. So it's automatically built in as an HA, and that's how we are guaranteeing 4 nines of SLA, right? So when you pick zone redundancy, what happens is we place these replicas in different zones. By zone, think of each zone as a separate data center, physical building. So what that gives you is isolation from data center level outages, whether it's network, power, or hardware. They're all completely isolated. So if your primary database goes down because, let's say, the building power went out or something else happened, then the second building is still up, or the third building is still up. They're all still local. They're still in the same region. So you'll still get the same performance that you need, but they're still insulated from each other from common outages. So it's available in some regions now, and it'll be added, more regions will be added in upcoming months. The second one is read scale out. So as I mentioned, for every database, we create 3 replicas automatically, right? These are all hidden today. But if you're using business critical queue, we allow you to connect to one of the replicas. So similar to always on premise, where you can specify application intent read only to do a read scale out and move all your read workloads to a secondary replica and not impact your primary. You can do that with Azure Database. Again, it's built in, so you just have to change your application connection string. You can also use this in conjunction with failover groups, where you can set up geo-distributed databases in any regions where SQL DB is. So you can have active failover groups between, let's say, primary running in East US and secondary running in Europe or anywhere in the world. And you can have a listener type connection string where application can be transparent to where the primary is. So that is fully supported too along with this. And then, so just to recap, so one of the biggest value for Azure SQL Database is, in addition to the relational engine, we provide a lot of value and investments, as you saw, whether it's security or HA or even things like hardware. I mean, a lot of customers we talk to, today if you have to go and create a fully managed enterprise environment on premises, it can take at least 6 to 9 months from procuring your hardware to setting it up, to setting up HA, backup security updates. You don't have to worry about any of this. Everything is built in for you. You just get there, get fast with database migration service. Managed instance makes it even more easier to just lift and shift with compatibility. And you can now focus just on your application and business and get all the value and not have to worry about managing the actual database itself. So we did a very quick overview of all the features. We have a ton of breakout sessions which will go deeper into each of these. Feel free to attend, and if you're not able to make it in person, it'll all be available on in YouTube in a few weeks along with the content. So that's all we had for today. If we'll hang around here if you have any questions, and then take it from there.